Hello students, myself Dhruv Patel. I am now here again with another lecture of fluid mechanics. So starting with the lecture and so in previous three lecture I have make you understand about the introductory portion of the fluid mechanics. Means I can say that it is one type of introduction of fluid mechanics. Quickly we can do the revision like some of points I have covered in the first three lecture, and we have studied about what is mechanics, what is fluid mechanics, types of fluid, and properties of fluid we have studied. But in the last lecture and in the last slide I have told you that that I will make a new lecture on the derivation of surface tension, on the capillarity derivation, and on the measurement of viscosity meter. Okay, so today I am going to teach you about the derivation of the surface tension. So stay tuned. So surface tension. Quickly, we remind the definition. Surface tension means what? Surface tension means the tensile force acting on the free surface of liquid per unit length is called surface tension. What? Surface and tensile force. Tension means tensile force acting on the free surface of a liquid per unit length is called surface tension. So surface tension like this. This is a water body which is moving from this to this, or you can say that we're moving this to this, and this is the length of the water body. In general, if the solid is not dipped in the water, the length will be like this. But as the solid material dipped in the water, whose density is less than the water density, so it will float on the water surface, but some of tension will be created here. This is known as surface tension. Okay, so derivation, we are going to study derivation. So which type of derivation on the surface tension is like this? Surface tension where on a liquid droplet. Liquid droplet means a rain droplet or a droplet from the water body, like when we are in the bathroom, we suddenly open the shower, the water drops come from it. It's like a droplet. So on a liquid droplet, on a hollow bubble, yeah, the bubble are also in hollow form, and on a liquid jet. Liquid jet means one type of cylinder which is filled up with liquid. So we cut into half the liquid jet and calculate the surface tension. Everywhere we fill the water, the surface tension occurs. It occurs on the water tank also. It occurs on the balloon fill up with water also. In each material or in each element, if we dip the water, the surface tension occurs. Okay. So here only we will study about the three general examples. Okay. So coming to the first example, which is on a droplet. Surface tension on a droplet. So this is the figure shows one type of drop of water. This figure, this is the drop of water. Cut it in half to calculate the surface tension. I have written it, I have mentioned that cut it in the half to calculate the surface tension, because we will never calculate the surface tension of the full material or the full droplet. Why? Because it occurs on the surface, and intensity means internal pressure also occurs due to surface tension. So if we cut it into half portion, the droplet will be things like this. After cutting the droplet into halves, it will look like this. Hide these two, and this droplet will look like this. Okay, this is the droplet, and this is the surface, and this is the hollow portion. This is the hollow portion inside. Okay, so now we know that surface tension is denoted by sigma. Okay, diameter of the droplet means this, from this to this is our diameter. Okay, and pressure intensity inside the droplet means inside the hollow portion the pressure intensity will occur. Okay, so now this is the surface tension. It will occur on the periphery of the droplet, on the periphery of the droplet here, because we have the word surface. The surface, it will be occur on the surface. It means it will be occur on the periphery, or we can say that on the circumference area. Okay, so figure shows that tensile force is due to surface tension. Or tensile force is due to surface tension. Okay, acting on the circumference of the cut portion. How tensile force due to surface tension? Anyone can explain me? When we pull two material like this, the tensile force will be acting on that. Okay, so tensile force is due to surface tension acting on the circumference of the cut portion of the droplet. Means this is the cut portion, and here the tensile force will be acting. Okay, so tensile force is equal to, we can say that, surface tension into circumference. Okay, surface tension into circumference. Circumference is this, and the circumference of the half droplet is pi into t. The tensile force is equal to circumference into surface tension. Okay, by which we get this formula. Now, the internal pressure, as I explained earlier in the first slide. Okay, the internal pressure, where it is occur? The internal pressure will occur in the internal area, internal hollow area. Okay, so figure shows that intensity of pressure inside the droplet on area. The area, what is, this is pressure, occur into area means pi by 4 t square is a simple equation of the circle area, pi by 4 into t square. Okay, so under the equilibrium condition means, as we can say that on the basis of Newton's third law. What is the Newton's third law? The force occurs in opposite direction and equal to each other. Okay, so when these two objects are pulled, okay, the force, the stress occurs in pulling. Okay, the opposite stress also will occur inside the surface of the surface of the drop due to water pressure. Okay, surface tension create and pressure intensity both are equal and opposite to each other. दोनों एक दूसरे से बिल्कुल opposite है और एक दूसरे के equally है. जितना टेंसर स्ट्रेस लगेगा उतना ही प्रेशर अंदर जाएगा, जितना कंप्रेशन स्ट्रेस लगेगा उतना ही प्रेशर उसके अंदर की सरफेस पे भी लगेगा ही टेंसर. ठीक है, so under the equilibrium condition the two forces will be equal. So intensity of pressure is equal to surface tension. We can say that on the basis of definition. So intensity of pressure is equal to pi by 4 p into pi by 4 t square is equal to surface tension into pi. Now pi get cancel out, t 1 and square cancel out, so the remaining is the equation of the surface tension on a droplet. This is the equation of surface tension on the droplet. I hope you get understand. If you haven't understand, then please comment me. I will make another presentation to understand you, or I will choose another method. But I am sure that you have understand. I have tried to make it as much easier as you can understand or as I can explain you. So please stay tuned, and I wish that all the online lecturer, make advertisement of please subscribe it. But I have also learned from the online lecturer, and it gets so much irritation that we put an ad of subscribe it. So I am not putting an ad that subscribe it, but if you like, then you subscribe it. Okay. So this is the first derivation, the surface tension on a droplet. Okay, I hope you understand it. So now coming to another derivation, and another derivation is, see, this this droplet is also saying that, okay, you understand it. Now on a hollow droplet, oh yeah, droplet also having a hollow surface. So what do you mean by hollow surface? Hollow surface means you can say that a hollow circular portion. If you can cut, I can say that if you can cut a hollow round, the layers like this. If this is a hollow circle, I cut it in the portion. So the portion will be like this. Okay, it will have two surfaces, internal and external. But I can imagine that this is a solid. If I can imagine that this is a solid, then the cut portion will be only like this. Okay, so on the basis of this, the hollow, wait, I erase all this thing, so you can get irritated. This is a hollow droplet. This is one type of droplet. The internal surface is this and the outer surface is this. So there will be two surface. So the surface tension will be occur on two surface. See, in a hollow droplet, there will be two circumference, outer side and inner side. So the surface tension will be occur on two surface. My mistake, in this position, you can write tensile force. This is my mistake. I'm sorry. So tensile force will be acting on two surface. Okay, and so it will be multiplied by 2. We have find the tensile force, we have find the circumference in the previous droplet. Okay, so it was surface tension into pi d. This is multiplied by 2, but the area will remain the same. Why? Because it has only one internal surface. Okay, because this portion is solid portion. Okay, so nothing will be changed. The change is only that it will, the surface tension, the tensile force will be multiplied by 2 because it occurs on outer side and inner side both. So pi by 4 d square is equal to 2 into sigma into pi d. So the equation will be this: P is equal to P sigma by d. Why? Because this d and this d will be cut. The 4 will come here and it will be multiplied by 2. So 8 and sigma by remaining this d portion. Okay, I hope you understand. Now coming forward to on a liquid jet. What? On a liquid jet. So on a liquid jet means, what is liquid jet? So this is a cylinder. If we cut this cylinder from this to this, okay, the liquid jet will occur like this. A piece of a cylinder is known as liquid jet. Okay, so it is full up of, this portion is full up of liquid or a water or a fluid. So figure shows liquid jet. Cut it, cut in two halves. If we cut in two halves, it will be look like this. Okay, and here it is the circumference. The circumference of jet will be calculated by this. This is the surface where tensile force is acting. Okay, here it will not act tensile force. The tensile force will be act here only. Okay, because the upper side is the hollow and lower side is the solid, and the liquid is below it. So circumference is equal to 2 into L. 2 into L. This one is one length, this is another length, so it will multiply by 2 into L. So tensile force, here again my mistake, it will be tensile force, not surface tension. Sorry, tensile force. Okay, so is equal to surface tension into 2L. Okay, the pressure occurs. Now, the pressure. Okay, so in last derivation, or what is the common definition, or what is the common place where the pressure occurs? We have studied earlier the pressure occurs on the internal surface area. Okay, so it is pressure P and the area will be D into L. Okay, this is D is means the diameter. D means the diameter which is shown here. Okay, so D into L, this is nothing but the area. Okay, area. So under equilibrium condition, both will be same. So P into D into L and the surface tension into 2L. The L and L will be cut. So P, equation of P is equal to 2 sigma by D, and sigma is known as the surface tension. So these are the genres where the general three example for calculating the surface tension. Like this, you can also calculate the surface tension for different shape and different kind of material. The the base is that the tensile force always act on the circumference portion of the cut portion, and the internal pressure occurs on the area, internal surface area. Okay, and for surface tension, the equilibrium condition is based on the Newton's third law. Okay, so in all type of material or in all type of element, you can work with this basic principle and you can get the surface tension of each type of element. Okay, so I hope you understand the surface tension. Thank you. If you have any query, you can comment me, and please subscribe it and please like it. Okay, bye bye. Take care. I will meet you with another lecture showing the capillarity derivation and the measurement of viscometer. Okay, after that we will complete the first chapter. Okay, bye.